All right, welcome back to Diamond's Concept. So what we're looking at today is just a continuation of the part one that we did on using the sum and product formula. All right, in trigonometry. So today what we're looking at, we're going to look at a few problems, maybe about three. First one here is that we're, without a calculator, we're trying to find the sine of the 75. So we want to find the exact value of sine of 75 without a calculator. One of the first things that you have to do is to always remember the special angles from the special triangles or in the unit circle that are able to give you these values, whether by adding or subtracting. So in looking at this 75 here, I do realize that I could get 75 by doing this. So if I rewrite this as sine, open bracket, 45 plus 30 degrees. So sine 45 plus 30 degrees. I'm seeing now when I'm representing 75 as the sum of 45 plus 30. Now, what I need to do is to now write the identity using these angles for the sine of 45 plus 30. So I'm going to use the sum formula. For the sum formula for sine, it is the sine of 45 times the cos of 30 degrees plus the cos of 45 times the sine of 30 degrees. So with this said, what we're doing here, we're representing the sum formula for sine. Now, these values, right, can easily be attained from memory or from having a quick diagram. If you're in an exam, I can make your quick diagram while you're in the exam. Don't bring it in the exam. And then you could now pick up the values from these. For example, the sine of 45. So I'm looking at this sine. Remember that this is always being used. So, tower. We use the trig ratio all the time. So the sine has to do with opposite and hypotenuse. So sine of 45 degrees, opposite over hypotenuse, I'm seeing root 2 over 2. All right, so that is root 2 over 2. And I want to multiply this by the cos of 30. Cos is adjacent over hypotenuse. So you go where 30 is, right? And we're getting root 3 over 2, right? So we got root 3 over 2 there. And we want to add that to the product of the cos of 45. And the cos of 45, going back where 45 is, I'm going to get root 2 over 2. And I need to multiply this by the sine of 30 degrees. And I'm going to get a half. All right. So using those special triangles, I'm able to come up with these values. So all I'm going to do is just to carry out multiplication. All right. So basically then what I'm looking at is root 2 times root 3 all over 4 plus root 2 over 4. Well, depending on how I want to do this, there are many ways to represent this answer, right? So this could be represented as root 2 times root 3 plus root 2 all over 4, since 4 is the common denominator. But if I do this, I do realize that I could factor out root 2, and then I will have root 3 plus 1 all over 4. So we could represent it like that. Depending on who you are, you maybe, or you could have represented it like this. Root 3 times root 2 is the root of 6 plus the root of 2 all over 4. That's another representation of that. But definitely, we do have the exact value of the sine of 75. All right, let's look at another problem. The cos of 15 degrees could be obtained by simply using the difference formula. So it's going to be cos of 45 minus 30 degrees. We could do that. Could have used 60 minus 45 as well, right? Now, so now we're using the difference of the cos. So we need to flesh out what that formula is. So it's going to be the cos of 45 times the cos of 30 degrees plus the sine of 45 degrees times the sine of 30 degrees. When you're working these, though, you have to make an effort to at least remember these formulas if they're not given to you in the exam, right? Now, from this, now we're going to just go to our special triangles to see what we have. So we're looking at cos 45. So I'm going to be looking at this triangle right now. Cos of 45 is root 2 over 2. And I'm going to multiply that by the cos of 30 degrees. I'm going to be looking at this triangle. Cos of 30 degrees is actually root 3 over 2. And then we're going to be adding the sine of 45. And the sine of 45 is root 2 over 2. And I'm going to multiply this by the sine of 30. And the sine of 30 degrees is definitely a half. So we're going to put this together. I'm getting root 2 times root 3 over 4 plus root 2 over 4. I could put everything together. Root 2 times root 3 plus root 2 again over 4. I could simplify if I want, depending on what the question may want. I could factor out root of 2, open a bracket. I'll have the root of 3 plus 1, and all of this over 4. Or I could have represented this as the root of 6 plus the root of 2 all over 4. Diverse ways to represent our answers, and we're good there. So for this one, I'm looking at we want to find the exact value of the cos of 210 degrees. Definitely 210 degrees is not a special angle, but we could combine two special angles in an effort to help us with this. For example, we could look at this as the cos of 270 minus 60 degrees. You have to see this for yourself, though. Now, let us flesh out in terms of the difference for cos, which is going to be cos of 270 times the cos of 60. When it's a difference for cos, you add. So it's going to be the sine of 270 times the sine of 60 degrees, right? So we're able to get these out and running right now. Let's go further. What are we looking at? You're definitely looking at this part here. We should take a quick look at this. 270, right? Cos of 270. We could see that by looking at the unit circle right here, right? Where 270, this is 0 degrees, this is 90 degrees, this is 180 degrees, and 270 degrees, it's right here. As you could see, the coordinate for that is 0, -1. Now, if you really look up here, we're looking at the x would be cos and the y is sine. What it means is that the coordinates are in a relationship with cos and sine, where cos is the x value and sine is the y value. So what it means that the cos of 270 degrees is going to be 0 right there. So that's a 0. What it means is that I would have a 0 for the entire thing here, because 0 times cos 60 will be a 0, which means I can now focus my energy on the other part that is not a 0. For example, I am now focusing on the sine of 270 degrees times the sine of 60 degrees. 270 is also on the unit circle, where the sine would have been the y coordinates. It's a -1. So the sine of 270 is -1. And we want to multiply that by the cos of 60 degrees. And that is from our special triangle. Let's take a look. The sine of 60 degrees is root 3 over 2. My final response, I do have negative root 3 over 2, and that is cos 210 degrees. I could just conclude that it is negative root 3 over 2. And there we go. Let's look at another one. A tangent of 15 degrees. The tangent of 15 degrees can be represented as the tangent of 45 degrees take away 30 degrees. So that is using a difference formula for tangent. So the difference formula for tangent states that you'll have the tangent of 45 minus the tangent of 30 degrees at the top. And then what we're going to have is all of this over 1, then plus tangent of 45 times the tangent of 30 degrees. So with this, all we have to do now is to use our special triangles and then get back those values. For example, tangent of 45, let's look at this triangle right here. Tangent is opposite side over adjacent side, and that is 1 over 1, which is 1, minus the tangent of 30. So I'm now looking at this here, and that is opposite over the adjacent. Remember though that the root of 3 over 3 is the same thing as 1 over root 3. So I'm going to be using root 3 over 3 for that. And if you want to wonder, if you're wondering how, all right, if you have 1 over the root of 3 and we don't want to have a square root in the denominator, we're going to rationalize by multiplying the numerator and the denominator by the same thing, which is the root of 3. So we'll end up having the root of 3 at top. And then when a square root multiplied by a square root, the square root cancels, leaving 3. So that is the reason why we're using root 3 over 3 as 1 over root 3, right? Right there. So using that whenever it comes up, I will always be doing that. All right. So what I'm suggesting here, I'm going to be having root of 3 over 3. And all of that will be divided by 1. And then we're going to be adding that tan 45 again is 1 times tan 30, which is the same thing as the root of 3 over 3. So if we simplify this, we'll have 1 minus root of 3 over 3, all divided by 1 plus the root of 3 over 3. All right. So basically that's what we have there, and that's the exact value. If we want to push it further, then we could work out the top part basically. So the top part, if I just turn these into fractions, then basically I would have 3 minus the root of 3 over 3 at the top. So that's working out the fraction at the top. And at the bottom, I would have 3 plus the root of 3 all over 3. Can be represented as that as well, right? So that's fine. So we could keep it like that. So whichever answer that you feel comfortable working with, and this could go further. What if you wanted to push that further? For example, you have 3 minus the root of 3 all over 3, and then that will be now divided, which means if you divide, you could multiply and reciprocate. So it's going to be multiplied by 3 over 3 plus the root of 3. You could see that this cancel that. We could go further. What I'm having at the top is 3 minus the root of 3 all over 3 plus the root of 3. So it could go on and on. And now I can rationalize again. If I want to do that, I could multiply by the conjugate. So if I want to get rid of this down here, then I'm going to use the conjugate, which is to use a plus, which I have a plus that I have to use. I have to multiply everything by this, right? 3 minus the root of 3 times 3 minus the root of 3. So I could do that. Now, at the bottom, if you really look at this, I'm looking at the difference of 2 squared. For example, 3 plus the root of 3, and then 3 minus the root of 3. So at the bottom, what I really have is actually 9 minus 3. That's what is at the bottom, really, right? Because if I should do the file and carry out all of those down there, simplify, I'll end up with 9 minus 3, right? Because 3 threes, that's going to give me the 9. And then this and that would cancel out. And then at the end, root 3 with root 3 will give me a minus 3. So basically, the bottom part will give me 9 minus 3. At the top, though, we won't get that. At the top, as you could see, what we're going to have is the root of 3. We have 3 minus root 3 times 3 minus root 3. This is what is at the top. 3 threes will give me 9. And then I'll have minus 6 root 3. And then I'll actually have positive 3. So then I'll have 12 minus 6 root 3 all over 6. I could push this further, right? So if I push this further, I'm getting, I could 16 to itself 1, I'll get 2 minus root 3 for the final answer. How did I get that? We could take our time and do this at the side. For example, this really means that 12 over 6 minus 6 root of 3 over 6. You could see 6 into itself 1, 6 into 12, 2, 6 into itself 1, 6 into itself 1. So we're really left with 2 root 3 right there. So this is the final response. If you want to break it down in the simplest form, here it is. But we could have stopped at various places depending on what the exam requires. Thank you very much for watching Dilemmas Concepts. See you next time. We'll be looking at more stuff.